Alright guys, let's do LeetCode number 102, binary tree level order traversal. So, given the root of a binary tree, return the level order traversal of its node values from left to right, level by level. So right here is an example. We're given a tree, and what we want to do is essentially print not print, but I mean you could print as well, but basically return all the nodes of each level and have them all inside an array. So essentially you have an array, and each array will consist of each row of the tree. So for the first one, it will be 3, second one 9, 20, and the third one will be 15, 7. Okay, so basically to code up this solution, what you need is a queue. So what happens is essentially you will append the first element of the root of the tree, basically, onto the queue, and then you will essentially just pop off everything from the queue, and as you pop off the nodes from the queue, you will keep track of a level array variable, and you will use that to append the elements that you pop off the queue. And after you pop off the queue, what you want to do simultaneously, in addition to, of course, keeping track of the value that was popped off, you want to add all of its children, okay, the node that you pop off, right, all of its children back onto the queue. So for example, this one right here, you begin with 3, and so you pop it off, you append it, you get your level, right? So I should pop it off. Okay, you also have 9, and you should also append 20. So now your queue has 9 and 20. So you continue to iterate until basically your queue is empty. So you look at 9, right? You pop out the value, add it onto the level. So now you have like 9. So it's just right here, and then you have 20. You pop it off, right? The value, append it to the level, and simultaneously you also want to add the children back onto the queue. So yep, same logic over here for the queue. Pop them off, add children if any, pop off this one, add children if any, and once the queue is empty, which will happen once you reach number 7, you pop everything out. Then you can exit the while loop, and at that point you can return the result. So that is how we go about it. Okay, so first thing we can do is handle the base case. Well, if there isn't a root node, then we can simply return an empty array. And now for the queue, okay, you can just put the root as the initial value inside of the array queue. So again, right, while the queue isn't empty, you want to continue to pop things off. And how many times we want to pop things off, that depends on the array count. So for the elements, so for the counts, you want to pop off the elements from the queue. I'm going to pop it off at the end. Okay, and we also want to keep track of the level. So we will append the popped value. After we do that, you want the children. Okay, let's do left child and the right child. So if let left equals pop left, if this one exists, then we append the left node. Let right equals pop.right. If the right node exists, we append it. And then after we popped off everything from the queue based on the count of the initial queue count, we will add it onto the result. Array. Okay. Result append level, and let's give this a run. Okay, we add it. Okay, let's get some run. Okay, let's go on here. Let's see. Pen level. Putting 27 instead of 7 instead of 1. Okay, let's go through this line by line, see where mistake is made. Okay, so initially we have 3. Okay, so Q is 3 is okay. In the pop, we remove the last element. Okay, level pop.value. Okay, that's fine. So if we have a left element, we append it. Okay, looks fine. We have a right child, then we append it onto the queue. Okay, so this should be 20. We can do actually just print the queue at each level just to verify the values. Queue so okay, first one is okay 9, 20. That one looks good. The last element. Actually, I should remove the first. Right. Yep, this should do it. Yeah, so that is the idea. Yeah, with Q, you want to remove the first. Yeah, then it will work. So yeah, so maybe we just go for example, because if you haven't done this in a while, you will encounter these kind of things, but it's normal. Okay, so that, for example, rank 3. Okay, then this is your Q, right? And then let's do level, and then let's do result as well. Okay. Okay, so 3, pop it out, right? Remove the first element, pop first. So now you append the value 3. Okay, so now you check if there's a left child. Yes. So 9. Check if there's a right child. Yes. So 20. Okay, so now you append the level onto result. Okay, now a new loop. Okay, empty. Okay, so 9. Pop and add here. No children. So we can remove this. And now 20. Pop out. Add onto the level. Okay. Do we have any child? Yes. So 15 and 7, left and right. And now you append the level onto the result. Okay, now a new loop. Result is empty again. Q, pop the first one. Right, pop it out. Append it onto the level. Any child? No. Okay. Now you pop the 7. Okay, 7. You check any child. Nope. And that is all you have. So now you can just append it onto the result. And this will give you this right here. Okay. 3, 9, 20, 15, 7. So this is how you print a binary tree level by level. That's it. Oh, space-time complexity. Let's not forget about that. And the time complexity would essentially be the number of nodes in the tree. So O of n. And the space complexity, well, you're just gonna essentially track at most the number of nodes on the tree. So that would be O of n as well. And yeah, that's it.